Okay, did you come up with an answer? When we left off, we talked about the predictive ability of regression. Of course, if we plug in 2 to this equation, we got a number that lied along the line, and so we were able to generate more information than we actually included in the experiment. Then I asked you to put 10 in. What if we'd done this 10 times a week? What would happen? Well, if we put 10 into this, we get minus 82 plus 70 for a y, or a height, of negative 12. Well, obviously you can't have a negative height of a plant, and this illustrates one of the most important things in regression is don't extrapolate beyond your data. Okay? If you wanted to say something about 10 weeks, then you should have had as a treatment 10 out here, or 12, something that would include 10 within the treatment range. So, obviously you're going to brush these things several times a week. At some point, this is just going to plateau out, right? At some point, it's not going to get much lower than, 30 some centimeters. That's it. You're just going to beat the plants up. So that's extremely important. Don't extrapolate beyond the range of data that you put. That's dangerous. And boy, there's so much of that in the media these days. I don't even want to get into that. Let's try another example here. So this is an experiment here where we applied different amounts of water as sort of a percentage of a maximum amount that we'd want to apply. And we measured the dry weight of a plant. And this is a plant, Prunus fasciculata, a drought-tolerant relative of the peach. And we want to know, can it get by with less water than the sort of maximum amount that we would want to apply? Okay, looking for drought tolerance here. And so we had the 4 treatments, 25, 50, 75, and 100% of that amount of water we would want to give. Measured the plant dry weight after we grew them for a while. Again, we did a trend line. Here's our data. Here's our equation. Here's our R-square. Let's see what we see in this one. Okay, so this is a little different than what we saw above. First of all, the equation of the line has a slope of 0.04, a positive slope, we think, of 0.04. Remember, we'd have to do the regression to see if it was truly non-zero. But boy, it seems awful close to 0, and it does kind of look horizontal. So the question would be, in running the regression, would a horizontal line going through here be just as good, really, as the one that they're actually showing, okay, within statistical confidence limits? The other thing on the R-square is that we see a 0.19. Remember, that's a number between 0 and 1. 1 means X explains 100% of the variation in Y. 0 means X explains none of the variation in Y. So here we only have 19% of the variation in the dry weight of the plant being explained by water applied. That's not that much. It means there's 81% of the variation in dry weight that were due to other things that we didn't measure, didn't control, have no idea. Okay? So I'll let you pause the video and do the regression and then come back. Okay, so what did we get? Let's go down and take a look at the p-value. Remember, all this other stuff is great, but you really want to look at the p-value. Water applied was the x variable, so this is the slope. And the p-value here, 0.15, that is greater than 0.05. We would conclude that the slope is in fact similar to 0. It's not a non-zero slope. So a horizontal line basically goes through there, as good as the one that we have. Okay, we don't really care about the intercept. It is non-zero, but so it's going to hit about right there, 13. But the important thing here is that this is a non-significant result. Okay, so in other words, there's no effect of any of the treatments we applied. We got the same growth no matter how much water we applied. And a lot of honor students will stop at that point and be disappointed with their experiment. Well, it didn't work. Yeah, it did work, actually. Because what this is saying is that you can actually go down from 100 to 25% of water applied and get the same dry weight. So in fact, that is saying that this thing is drought tolerant because it can get by with a lot less water. Exactly what you wanted.